All right, we want to prove that. First, we're going to let r prime be r of bar x, because I don't want to have to write these brackets all the time. They're really hard to draw, and there's 4 of them. It's just so much work. I can't be doing all this work. So I'm just going to write r prime. So we got to prove r prime with plus and 0 is an abelian group. Let's see here. We've proven this. We've proven associativity because it follows just the same way that it does in the polynomial case. If an is in r prime, I'm going to use an to refer to like an equals a0, a1, all the way up through infinity, and each of these ai's are in r. An plus 0 equals, you just add it in, an plus 0 equals an, equals 0 plus an, equals 0 plus an. So 0 is the identity. Obviously, 0 is in r prime. If an and bn are in r prime, then an plus bn, which is an plus bn, is in r prime, since each ai plus bi is in r, because r is a ring. Also, an plus bn, an plus bn, bn plus an, because r is a ring and so it's abelian. Also, negative an is in r prime, and so negative an is just like ai, the ith element, or the ith element of, well, not the ith element, the ith index of negative an is just negative ai. So, and negative an plus an, negative an plus an, you can tell I'm just thrilled about checking all of these trivialities. Plus negative an. So an inverse is minus an, which is clearly in r prime. Hence, r prime plus 0 is an abelian group. I guess I should be more excited because this is my last exercise of this set, and I've done like, I don't know, definitely over a dozen exercises in a row, and I'm almost done with this. Wow, that's really sloppy writing. I'm going to keep going. I now claim r prime with dot and 1 is a monoid. An bn is, by definition, each n is sum from j equals 0 to n, a, j, b, and minus 1j. This is obviously an r prime because each a, j, b, n minus j is in r, and so the sum of them is in r, and so each index is in r, and so the thing is in r prime. And 1 times an equals, now this is where it's a little bit not completely trivial. So j equals 1 to n, 0 times a. Remember, this 1 is 1 and then zeros. And so what happens is when you're taking j equals 0 to n, let's see here. So the first one is going to be a0. The a0, we're going to end up with a 1. So here this is going to be 0, or it's going to be 1j, and this is going to be the a and minus j. And so we're actually using A in place of B here, so that makes it a little confusing, but it's not too bad. So if we look at this formula, when j equals 0, we have the 0th entry of that's the word, the 0 entry of 1, which is 1, and that multiplied by n minus 0, so an. And then for all the other ones, for j greater than 0, the jth entry of 1 is 0, and so you're just multiplying 0 by a bunch of things. So this is going to be equal to just an. And let's see here. What else is this? And so then, if we go backwards, go from j equals 0 to n minus 1, aj times 0 plus an times 1, that's just a trivial equality. But then this you can check is the formula for an times 1. So 1 in R prime is the multiplicative identity. Thus, R prime dot 1 is a monoid, and hence R prime is a ring. And this completes our proof.